going to set a timer. So I rather optimistically titled this Simplifying the Study of Consciousness with Shared Experience, Shared Identity and Shared Information. Surprisingly, it's hard to simplify consciousness. So I didn't have much luck on that front. The general premise is to try and talk about the idea of sharedness and to use it to talk about structure. So I'm going to try and talk about shared information, shared experience, so not necessarily all of experience, but also shared identity, which is something that's even harder to grapple with. So I'll probably should define these things again. So when I say shared information, people have a lot of different conceptions about what information is. When I say information, as a subpar information theorist, I'm talking about it in the terms of information theory. So when I say that, I say shared information is information that is shared in the information theory sense between multiple systems, or possibly represented by multiple systems. And I'll try and be a bit more explicit about that in a second. When I talk about shared experience, I'm going to mean when some part of phenomenology is shared. Again, there's still some sort of patchy areas there. So maybe between one or multiple people or entities or whatever we're going to talk about. And I'm going to be I'm going to make it very clear, not the whole of experience, because everyone seems to think this is never going to happen. So we might just be restricting ourselves to just part of phenomenology. And lastly, probably the most controversial of all of these, that's the little star, is the idea of sort of shared identity. I think this is probably the most abstract one. So this is going to be when I'm talking about, in an abstract way, the idea that sort of what is a person is overlapping with some other kind of person. And I think this is probably the thing that everyone's going to think is the most controversial. But we're going to roll with it and see where we get. So I should say, I'm not a philosopher. I'm not super deep in this. These are just some thoughts that I have. And given the nature of this conference, I would kind of like to share and kind of give you some food for thought, really. So why talk about information at all? Well, information is really powerful in terms of mathematics. It captures all kinds of patterns. It's not just linear, it's not exponential, it can be really any kind of pattern that exists in the data at all. And it captures those relationships at all scales. So if you're doing a neuroscience experiment, you expect to see some of that information using the scale of the recording that you're making. And it's generally quite straightforward to calculate. So I mostly work with entropy, and you can see this is the formula. It really isn't too crazy. So something that's really powerful about information is that you can talk about it being shared between multiple systems. So if I have two variables, let's say, for example, race and whether or not someone got into university, you really want to know if there's a relationship between these things. And it's quite easy to quantify whether or not there is a relationship. So I love these Venn diagrams. They're essentially all of my work ever. This sort of middle part of the diagram represents information that is shared between these two systems. So ideally, you'd want this thing to have sort of nothing in it. Usually there should be no relationship between someone's race and whether or not they get into university, for example. But the real power of information theory is that you can do this with essentially any kind of variable you could possibly want to define. So it really could be anything, provided that you set up the question in the right way and you set up the experiment, then you can more or less take any combination of things and just ask if there's some relationship between them. I'm not suggesting this is a good thing to do, but especially if you want to talk about quantifying, perhaps in a neuroscience experiment, maybe you actually want to talk about sharedness between brain activity and some kind of stimulus. How much does the stimulus inform brain activity and vice versa? So you might have someone's EEG, you might take an EEG channel, and say we've got Alex is doing some kind of experiment, doing lots of repeated trials, someone's flashing lights in his face. We want to know how much does maybe a certain EEG channel or a brain region or an fMRI parcel actually represent the stimulus he's being presented with. And this is something you can definitely quantify. And it's really interesting and it's nice to know because it can tell you, how different regions of the brain are capturing all patterns about the stimulus, not necessarily just neuronal linear activation, right? Which is something which we're very, very familiar and very happy with. So this is where it gets a bit more abstract, is what if we want to start quantifying how similar people's brain dynamics are? So suppose we have two people, we'll have Alex and Belle, and they're both doing the same experiment, sitting the same trials, and we want to take maybe the same EEG channel in roughly the same position, and we want to ask how much similarity is there between the representations of the stimulus that Alex has and the representations of the stimulus that Belle has. And you can do this, ish. It's actually surprisingly hard to find this number in the middle. It's a sort of problem in information theory that's not completely resolved. We have some good ideas for how to do it. But in principle, if you could find this number that should be in the middle of this diagram in the right way, then you could quantify to what extent, in terms of representations, Alex and Bell are representing the stimulus in a similar way, which is kind of nice. So if we talk about people having the same representations of information, or processing information in the same way, processing structure in the same way, you should think that if people have identical representations of things, you might want to think that they have identical phenomenology. Of course, there's a few asterisks to that. But as I say, these representations could be very, very non-linear, very complicated, very abstract. It's not really possible to know exactly what these representations are going to look like. And indeed, if we knew, then we'd know exactly what kinds of structures we would need to be looking for in the brain. So one great reason, one further great reason for using information is because it seems to capture all of these representations in what feels like a more universal way. So in some sense, if we just looked at neuronal activation, that's already a surprisingly macroscopic, in terms of how the universe works, is already a very macroscopic structure. And the activation of neurons doesn't necessarily feel like something that the universe or the mechanics of consciousness would be tracking. Rather, I would expect that the sort of mechanics of neurons are trying to mimic this other thing, which is causing phenomenology. So let's take this idea just a little bit further, just to convince you a bit more on this idea of shared phenomenology and shared information. So if your brains, we're two people, two brains, doing the exact same thing in response to a stimulus, right? You would expect to be able to quantify this. You'd see that they are essentially the same in terms of the information they represent. So you can actually see this. So you would see that essentially all of the information in these brains would be shared between the two of them. And conversely, if two brains are doing completely independent things, you'd expect to be able to see this as well. There's no relationship between what's going on in one brain and the other brain. You should probably not expect that there's much of a relationship between the phenomenology either. Okay? So what I've given you here is some kind of weird sliding scale between these people having the exact same experience versus they're probably not having the exact same experience at all. It's probably completely different. And information seems to capture that particularly nicely. Okay?
Sorry, is this for the same stimulus in both cases?
Yes, I'm being a little bit abstract deliberately, but you could say, let's say we give them any number of stimuli and we somehow find a nice way of quantifying this. Exactly how you phrase the question, as I say, is a bit more complicated. Okay, so we have a lot of assumptions about what human consciousness is like. I'm sure we all know. For example, it comes along with sensory processing. We have a sense of self. We have constant annoying emotional states. We have a sense of valence, positivity and negativity. We have, intriguingly, a sort of feeling of time. And we also often have a sort of sense of location where we are in response, in relationship to everything else in the world. So you might think, maybe, the brain is just sort of simultaneously representing all of these things. So let's talk about it just in terms of information. What if we can patch all of these different experiences together by saying that the brain is simultaneously, in terms of information, representing all of these different pieces of quality, all of these different pieces of information? And if you think about it this way, unconscious processing would then correspond to information your brain is describing which is lacking in some way of one of these things. So imagine there's some information that's going on that's got nothing to do with your senses, nothing to do with you, nothing to do with your selfness, some information in the world which has nothing to do with you. There's no reason for you to experience it. So this is roughly the idea I'm going for, that we can maybe bind together phenomenological experiences through the sharedness of information. Okay. So I thought I'd make it even more fun and talk about how things can change over time and over other, scenarios. And sort of talk about how information is sort of more general than we often assume. So let's suppose for a second that the universe only has 6 time steps or something, or I just take, for example, Jonathan's brain, and I just take it at 6 times. It's going to do lots of funky, interesting maths things, as his brain does. And what I'm going to do is I'm going to do something kind of strange, and I'm going to leap into the future. I'm going to pull his brain out, and I'm going to pull it back again. And what I'm going to do is I'm going to essentially take all of his brains and line them up here on the table at these different times. So in some sense, I now have 6 Jonathans evolving over the table rather than over time. the information representation of what Jonathan was thinking about is still, in a sense, there, but now it is not evolving over time. It's sort of been displaced in some way. This tends to make people kind of uncomfortable. I know I keep bringing this up in my lab, and it seems to be hard for people to want to say that these are the same person somehow. But if the information is the same, if the representation is the same from the information perspective, it's sort of hard to see why the common thread should go through time and not necessarily over space. So why don't we just allow this to be the case? You know, it very much could be. This is probably what I would expect to be the case from the information theory perspective. And this has consequences. So if you want to talk about different systems, for example, not necessarily evolving over time, but evolving over space, then you start to wonder, are they the same system? Are they the same person? Are they the same entity? IIT seems to imply, for example, that we can't have conscious machines because the system is changing all the time. Nothing is really recurrent or intrinsic to the system, even though the information being represented seems to be the same. So from an information theory perspective, this representation feels the same. That is to say, from the perspective of IIT, it feels a bit like we're preferring some information about time versus some other kind of information, which feels unnatural from the lens of information. So let's have fun. Here's an apple. Look at the apple. Study the apple. Consider its redness, its deliciousness. How much it would hurt if someone threw it at you, I don't know. Forget the apple. The apple's gone, okay? Was never there, and now it's back again. Surprise, who knew? Okay. So this apple, I've just shown it to you 2 times. So let's just take one person. Let's take me. I've also been looking at the screen. I've seen this apple. In some sense, I have the same representation of this apple 2 times. But you also probably also had some version of the representation as well. There was something shared in our experience of this apple. And that might be very abstract. It might be, for example, if I asked you all to write down what the object was, we might write the same letters. But there is some kind of representation there that is the same. So it seems like this apple appeared in my head twice, in 2 different times, but also in all of your heads. So it's all over the place. How many apples were there really? And this seems to be a quite hard question from, or at least it's a really interesting philosophical question from the perspective of what is information. You know, it seems that this information appeared in multiple places. So how do we keep track of whose apple is whose? You know, why is this phenomenological apple, all the information about it, different to this other one? There's things you can say, but maybe you don't need to try as hard as you think you do. This apple, we might just kind of overlap on this thought of this apple temporarily. So we all shared in some possibly very minute way something about the structure of this apple, knowledge of the word or structure of the phrase. So we might not need to keep track of identity as much as we think we need to. So this sounds very strange. So I thought I might rephrase it. I was last year at Models of Consciousness in Oxford. I was talking at Adam Barrett about this, and he tried to provide a sort of translation back at me, which was nice. So imagine this. I clap, right? And the question is, in the sort of space of all phenomenological experiences that ever happen, how many times did the clap happen? Did it only happen once, or did it happen enough times for everyone in the room? And I know this sounds very abstract, but I do think it's a genuinely interesting question to ask. Let's say, this translation brought to you by Adam Barrett, but not necessarily endorsed by Adam Barrett. Okay. So the overarching message for what I'm going for is I want to tell you maybe in some scenarios, it might make sense to think of these things as being the same. And I know this feels very controversial. Or they might be completely different. It might be that you can never share information with anyone. You might never share experience with anyone. I don't know, and I personally haven't decided which side I fall on this. You know, I just think it's philosophically really interesting to ask. So I mentioned before, I came into this wanting to simplify the science of consciousness. And the original plan was to come up with some nice sort of philosophical directions and make some sort of definitions and say, this is the logical relationship between these things, and it's so clear if you do this, then obviously these 2 things are contradictory. But it kind of got a bit out of control very quickly. And I felt like I wasn't really simplifying the science of consciousness. So happy to talk about those if you want to with me at some point. But I do think reasoning about the relationship between shared experience and shared identity if you want to represent things in terms of information, in terms of shared information as well, then you can probably simplify the sort of degrees of freedom of consciousness. So this diagram, I remember Sabine Hossenfelder, I think, actually retweeted it, which is essentially a sort of map of all of the different sort of theories of consciousness that we've had for quite a while now. So, in summary, we might be able to simplify the landscape of possible theories by committing in certain directions to answers to the questions of the relationship between shared identity and shared information and also shared experience. It might be that you can never share these things. And occasionally it might make sense to treat these three things as the same, as your representations just appear over and over again, and that's the thing that links you together. And if you do it this way, it's very testable. There's a really nice thing that comes out of this. If you follow the sort of natural direction that information theory takes you, it's much more empirically testable. Because information appears at all scales, because it appears at all granularities and definitions, anything you would see empirically is there. It really is information that was there. It might not be all of the information that was there, but you measured some of it. So it's actually relevant. So if you want to try and test this, in principle, you can ask, are the information representations actually the same? And this is a question you can actually answer using neuroscience, essentially. And as I say, I find it personally a little bit odd that when information so much wants to be at all scales and all patterns and all possible representations, that the leading theory doesn't really feel like it obeys the philosophy of information itself. It doesn't feel like it obeys how information wants to be treated. That's what I say. So this was all, as I say, very abstract from what I normally do. So what I normally do, I thought I might say, I work on this business of understanding the structure of information. Because if you can understand the structure of information, you might understand what it means to share information. As I say, not actually a solved question. So I work on breaking information down into sort of little qualitative pieces that you can put back together again. We actually had a sort of new way, which I think is especially, I wouldn't say it if I didn't genuinely believe it was exceptionally natural to do it this way. It has a lot of really lovely properties. And we called it this logarithmic decomposition. And I would obviously love if you want to go and have a look at it. It's a bit terse, but I do think it's really a great way of thinking about sharedness of information. And you can take all of this, as I do, and you can actually apply it to data. You can actually do science with it, and you can think about shared information, and maybe say something about shared experience. So actually, I work also on sort of information representations in the brain in sort of Alzheimer's disease to see, hopefully try and understand what the altered experience of someone with Alzheimer's disease might be like. And I'm hoping to do sort of perhaps synesthesia experiments soon, or some work with synesthesia data, and ask, are the information representations of certain stimuli similar in some way? Which could be a really, really fun question to ask. So I'm going to end with the plug. I will at some point be thinking about looking for a postdoc. So if anyone has any positions, I just thought I would make that known. And it just leaves me with time to finish. I want to thank my supervisors, Dan and Pedro. Dan is on the more empirical side, and most of my work with Pedro is in information theory, and it's a brilliant unity. I'd like to thank everyone else at the Cambridge Consciousness and Cognition Lab and Pedro's lab at Imperial in the Neural Information Dynamics Lab. So thank you very much.